Assalamualaikum. Hi guys. In this video, we are still in subtopic 3.2 about periodicity. So we are going to learn about the trend for ionization energy. First thing first, what is ionization energy? The definition of ionization energy, we are going to separate them into first ionization energy and second ionization energy. Let's go to the first ionization energy. The symbol is IE1. 1 here to indicate it is the first. First ionization energy is the minimum energy required to remove 1 mole of electron from the outermost orbital, or in this case, from the valence shell in 1 mole of neutral gaseous atom to form 1 mole of gaseous ion from its ground state. So in order for you to understand how the equation for first ionization energy, first thing first, we got gaseous atom X. So make sure you put the face for X because it is very important. Due to its definition itself, you have to mention gaseous atom. So that's why you have gas phase here. And you will take out 1 electron from the outermost orbital. So that's why the charge will be positive and the phase still the same, gas phase. So this is what we are referring to, 1 mole of gaseous ion. So if I want to calculate the total charge, whether they are balanced or not, here we got 0 and here we got positive 1, minus 1, because the charge for the electron is negative 1. So I will have 0 for both sides. So this is the first ionization energy. We are going to continue for the second ionization energy. We are going to take 1 mole of gaseous ion here and we remove 1 mole of another electron from it to form X2 plus, 1 mole of positive 2 gaseous ion. So you can see that the charge still balanced for both sides. Here is positive 1 and here is positive 2 minus 1, we got positive 1. So this is how you want to define two different ionization energy based on how many electrons you removed. Next, in order for us to understand the variation in ionization energy, you have to understand what ionization energy did. So ionization energy is the energy required to remove electron. So we know that electron got negative charge and it is attracted to the positive charge of nucleus, because in nucleus we only got proton and neutron. Proton is positive charge, neutron is neutral. That is why electron will attract towards the nucleus. Ionization energy will always has positive value because the process is endothermic, and it depends on the strength of attractive forces between nucleus and valence electron. For example, if I got stronger attraction between nucleus and valence electron, it means that I need to use more energy to remove the valence electron because the valence electron is very close to the nucleus due to the stronger attraction. Hence, higher ionization energy. So this is how we want to determine the magnitude of ionization energy. We can make a summary. 3 different factors influencing the ionization energy. The first one is atomic size. The second one, effective nuclear charge, ZEF. And the third one is shielding effect. So we are going to take a look how these 3 factors affect the magnitude of ionization energy. So we have here, based on atomic radius or atomic size, if I have larger atomic radius, it means that the attraction between nucleus and valence electrons is weaker. That is why we only use little energy to remove the electron, hence lower ionization energy. However, if we have effective nuclear charge with higher amount of it, it means that the attraction between nucleus and valence electron will be so strong So we need more energy to remove the valence electron, hence higher ionization energy. So this is the trend when we use layout pizzas. I hope you are still remember about this. We are still relate to this layout. Next, we have shielding effect. If we have larger shielding effect, what will happen to the attraction between nucleus and valence electron? It becomes weaker. So we only need a little energy to remove the electron from the valence shell. That's why lower ionization energy. So for the shielding effect, I hope you still remember we are going to use layout and SAS. So both of these factors are related to the atomic radius. Now let's focus when we want to describe the ionization energy across the period. Across the period, you have increasing proton number. Then effective nuclear charge also increases. That makes the forces of attraction between nucleus and valence electrons become stronger. Hence, the atomic size of atom decreases or getting smaller. So these all adalah points yang you have to write when describing the ionization energy across the period. And this is based on layout pizzas. But you cannot stop here because you are still not telling the trend for ionization energy. So when the size decreases, you can understand that the force of attraction makes the valence electrons pull closer to the nucleus. That is why you need more energy to remove the valence electron. Thus, ionization energy increases when moving across the period. How about the variation of IE down the group? So when going down the group, principal quantum number increases, or we can take a look at the number of shells increases. Hence, the shielding effect also becomes larger. As a result, the nucleus attraction with the valence electron becomes weaker. Hence, the atomic size increases. So this is based on layout and SAS. However, to describe and continue from this point about the ionization energy, when the atomic size is larger, it means that the nucleus attraction with the valence electron is very weaker. So you don't need more energy, you just use less energy to remove the first valence electron. That is why ionization energy decreases when descending the group. So for the general trend for first ionization energy, based on going down the group, first IE decreases, and across the period, first IE increases. So this is the general based on first ionization energy. So I hope you are clear how to describe based on specific element using layout pizzas or SAS. So that's it for this video. I will see you in the next one. Bye!